Students, in this video we are going to see that another method of solving a differential equation of higher order. So the previous all the videos we have seen with solving a differential equations when you have a homogeneous equation, non-homogeneous equation, and non-homogeneous if you have in the f of x function in terms of exponential, and if it is there in the polynomial, or if it is there in terms of a trigonometry, that is sine or cos x format, we have seen it, right? And one more method also we have seen when you have a variable coefficient. So remaining all the type has been discussed with the constant coefficient. The last video we have seen for the method, it is variable coefficient. Under the variable coefficient you have two methods. So one we have seen in the last video, which is nothing but it's a Cauchy's differential equations, right? So in this video we are going to see the variable coefficient for the differential equation, how to solve. The method is called as an Legendre's differential equations. So what is the difference for the Cauchy's and Legendre's? So if you take the Cauchy's equation, what we have seen, the coefficient of your differential equations in terms of it is x squared, x power n will be there when you have a nth derivative coefficients, right? So here you have a coefficient is little changes. So you can see that the Legendre's differential equations, the general format, ax plus b the whole power n, d power n y by dx power n plus ax plus b the whole power n minus 1 into d power n minus 1 y by dx power n minus 1 plus etc. plus y, which is equal to phi of x. So it will be in the format of the coefficient as ax plus b the whole power n for the coefficient of your nth order derivatives, right? So now in that cases how we can do? So what we have done there, it is taken in terms of x squared will be there, right? So it is considered as a term of t, which is, what is that? We have taken depends with the function what has been there in the Cauchy's. Here we are going to take the t, it must be in log of ax plus b. Okay, so here you will be having ax plus b. Both side you can apply for exponential. Log and exponential will get cancelled. So you will get only ax plus b, which is equal to e power of t. Okay. So what we did, do you remember for the Cauchy's? So in the Cauchy's we have to consider in terms of you have a term e power t will be nothing but is in x, right? So we have considered in terms of a log x. Here you will be taking log of ax plus b. So whatever you have the term in the format, you are supposed to be considered. So when you consider like this for ax plus b is equal to t, so entire equations to be converted in terms of t. So how we will convert the differential operator? So differential operator is nothing but ax plus b the whole power n, d power n y by dx power n to be written like this, a power n into d minus 1 into d minus 2 up to the term which you have till you have to write it and 1, right? So now you can go with the square. It is ax plus b the whole squared into d squared y by dx squared is nothing but a squared into d minus 1 into y. Then ax plus b will be dy by dx is equal to ad. So at the max you may get in terms of power cube, and maximum problem has been discussed in terms of your second order differential equations. Okay, so directly you can substitute when you have ax plus b the whole squared into d squared y by dx squared in terms of a differential operator to b, that is nothing but here d is nothing but d by dt, because you are considering, you are converting in terms of t. Okay, so now you can see that with the example. So we'll go with the first question. It is 1 plus x the whole squared d squared y by dx squared plus 1 plus x into dy by dx plus y is equal to 2 sine log of 1 plus x. Okay, it's clear. The question will never mention you are supposed to use Cauchy's or Legendre's. You have to identify, depends with the coefficient, whether you have a variable coefficient. If it is there a variable coefficient, what type of variable you are having it. So you can see here the variable coefficient what I have, it is in terms of like what is that we have seen the previous, you can see ax plus b format, right? So you can tell this x plus 1 you can write it, so it will be very comfortable to understand. So ax plus b, so a value is 1, b value is also 1. So log of ax plus b to be taken as an t, right? So here log of 1 plus x you have, which is equal to t. Now what is your 1 plus x? Take exponential on both sides, exponential and log will get cancelled. The left side only 1 plus x, which is equal to e power of t you will get, right? So now you can go with the substitution part. So what do we substitute? 1 plus x the whole square into d square y by dx square. As per the general term, I supposed to take a squared. So a value is 1 here. So we'll get d into d minus 1 into y. Similar, x plus 1 into dy by dx is a into dy. A value is 1 here again. So we'll get only dy. So now you can substitute this all the four to the given equations, both left side as well as right side, so that the complete equation will convert in terms of only, what is that? In terms of t. So what is that? First one, d into d minus 1 into y. So y I have written separately, plus what is that? 1 plus x into dy by dx. It is nothing but dy. So I'll get only d. Then next term I have only y. So I have written only 1 into y. Okay. It is equal to, right side what I have? 2 sine of log of 1 plus x to be written as an t. Isn't it? So I can write 2 sine t. Now you can simplify this equation. D you can take inside. It will become d square minus d plus 1 into y, and the right side remains same. Here d will get cancelled. You will get d square plus 1 into y, which is equal to 2 sine t, isn't it? So you can see here it is a normal differential equation of your higher order. So what I can able to do, it's a non-homogeneous equation. Right side I have in terms of trigonometry, left side just you can solve in terms of homogeneous, how we will solve it, right? So first you can convert an algebraic equation by replacing d is equal to m. I'll get m square plus 1 is equal to 0. So m will be plus or minus of I, isn't it? So it will go under for which case? It will be a third case. So now complementary function, how it will be? Third case means e power alpha x. Alpha value is 0 here. C1 into cos beta x, right? So beta value is 1. So instead of x you should write t, because we have converted variable in terms of t. In the last answer you can convert in terms of x. Okay. So c1 cos t plus c2 sin t. Now you have to go with a particular integral. So how that particular integral will be? You have a term of 2 sin t, isn't it? So 2 sin t by f of d. What is your f of d? It is d square plus 1. So d square plus 1. It is exactly with your type 2 problem, isn't it? So what I have to do? D square to be replaced by minus a squared. So replace minus a squared. What will happen? It is a minus 1 plus 1 will go for 0. Since the denominator is going to 0, what you have to use? You have to take a multiple with a independent variable. Here the independent variable is t, isn't it? And take a differentiation of the denominator. So I will get 2d, isn't it? So d square will become 2d. So 2d into 2t into sin t. So this 2 will get cancelled. You will get only t into sin t by d will be having it. So either you should multiply and divide by d, or directly you can write 1 by d is nothing but inverse of your differential operator, right? So it is nothing but integration of your sin t. What is that integration? 1 by t of sin t is nothing but inverse differential operator. Okay, remember 1 by d into sin t, it is nothing but integration of your sin t dt. It will become minus cos t. So this t already which is multiplied because of denominator is going to 0, right? So that to be written here minus t into cos t. So we have done complementary function as well as particular integral. So now you write it complete solution. Y is equal to yc plus yp. So c1 cos t plus c2 sin t minus of t cos t for your particular integral. What I have to do? I need to change it your t to be converted in terms of x. So c1 cos log of 1 plus x will be your t, isn't it? Then c2 sin of t is nothing but log of 1 plus x, and all. Here minus t is the log of 1 plus x and cos of log of 1 plus x. So this is your complete solution of your given, what is that? In terms of a variable coefficients under for Legendre's differential equations. Okay, so some more assignment has been given here for the practice. So it is ditto like here it is given ax plus b the whole squared. A value is 2, b value is 1. So to be replaced by a squared, 2 squared into d minus 1. So remember to replace the term, and right side also to be replaced it, and try to check whether you are getting this answer similar like your which you have discussed your example problem. Okay, then you have a one more here, a value is 3. Okay, only that is a changes, and the right side to be replaced wherever you have a x square plus 4x plus 1 is there, no? So remember to replace your x terms to all to be converted in terms of t, then only you are going to replace in terms of what is it, x in the last step. So you check this questions whether you are getting the answer. Okay, that's all. Thank you.